Right, greetings all, hope this finds you well as always, and it's now time for the latest update from the machine shop, where we've been up to and what we're on with. The observant amongst you may notice, if that sign has already told you, that this isn't the machine shop at Gromont. You're right, it's actually a small barn halfway up a mountain in Cumbria. I've spent the day, instead of busily sweating away on a lathe, I've actually been fitting a new start solenoid to this old girl. But the rest of this video, I promise you, is what we've been up to at Gromont. So, anyway, folks, here you go. This is what we've been on with this week. Right, another quick request that's come in is sorting out two of these fittings off the standard tank. These are fittings off the large and small ejector, and they're basically where a length copper pipe, i.e. those examples there, go into the body of the ejector. This fitting screws into the ejector, and then, so you can remove the pipe as required, you've got this arrangement of a nut and then also an olive. The idea is the olive slots into the body of the fitting. It will also go into the body of the land nut. The land nut can then be tightened up, and the pipe will in turn be silver soldered into that bore in the olive there. So the idea is let's make it all absolutely tight and solid, yet at the same time you've got a fitting that can quite easily be dismantled. The problem with these was it was discovered that the old olives were quite badly worn and damaged, and so the fittings were leaking. Upon examination, it was discovered that, first of all, the olives were worn out. Second of all, the tapers inside the body here were quite badly, well, they weren't true anymore. They were what I call belled, so they have been remachined. And then third, we also found out the nut was actually bottoming out on the thread here before it could actually tighten up. So the last job I've done is skim some off the end of the nut to give us a wee bit more room for it to tighten up. As I said, there's one, and the other is over here. There's the fitting. The land nut is still on one of those pipes, so I need to retrieve it. And then we've got this lump of scrap washout plug sat in the Myford lathe, which is going to yield us another olive, or at least that's the plan. So there you go, another job that's in progress. And there we go, there's number two. So as I said before, we have, just like the other one, we have a fitting, we have an olive that goes in there, and then the land nut on top of it bolts still down. The last thing I've done is just dry assemble them, put the nut on, run it down, just to make sure the nut doesn't bottom out on the thread on the fitting before the olive goes tight. So there we are, there's another job done. They can now go over here and they're ready to be soldered back on and refitted. So that's just another of the many running repairs that we're coming into now. Right, can't remember if I said this last week or not, but here we are, just making a few more felt pads for the last of the bushes for 825. These are going to make 3 pads, 2 for the intermediate bushes and 1's the remetalled big end. What we have is this sheet felt that I waved around last week. We have a very high-tech cutting instrument in the form of a common or garden hole saw without the central pilot drill, and all we simply do is apply one to the other, and you cut out a cylindrical plug, which when I break off the excess, which doesn't want to, looks something like that. What that will then do is it will then go into this very high-tech storage facility, of which there's already one in there. There you go. It will go into a very high-tech oil impregnation equipment. Yes, it is a baked beans tin. And then fill that with oil and then let them soak for a couple of days, and they're ready for use. So there you are, oil pads. Right, something else interesting that comes up every now and again is we end up finding ourselves needing special tooling. And an example of that will be this wonderful piece of precision here, which is an 1 3/8" drill. However, it's had its shank reduced to 1/2 inch to what we call a blacksmith's drill. It's been shortened, and then finally, as if it hadn't have enough indignity heaped on it, it's also had its cutting edges here ground to drill brass. Now, that was a entirely deliberate modification. It was during the work cleaning up 825's rod brasses, because I was doing it all on the radial drill, I needed a drill this size to drill out the oil pad holes. Now, somebody will say to me, you've taken a perfectly good 1 3/8" drill and you've ruined it for your own evil schemes. To which I would say, You haven't seen the bit I cut off. The drill had already been modified. It had already been modified to a flat bottom drill and that is the original end. That's the end I cut off. You can tell the difference. Mine isn't quite flat. Anyway, it had been originally modified as a flat bottom drill for purposes unknown, lost in the mists of time. The Morse taper on the end of it was not just bent, it was also very badly scored and damaged. And so it wasn't a mint unused, fresh out the box, never before seen by human eye sort of thing. So anyway, just to show that every now and again you end up having to take something and modify it to your own evil or nefarious means to do a particular job. For those wondering how the modification's done, it's very simple. First of all, grip it in the lathe on the shank here. The tapers on drills are usually soft, so that was easily machined away down to a 1/2 inch stub. And then very simply take an angle grinder with a slitting disc in it, cut off the excess, and then with the aid of a common garden bench grinder and a drill gauge, and I will admit it was done in a bit of a hurry, which is why it's not the best grind on God's earth, regrind the point, and then just simply blunt the cutting edge here, flat it off as it's sometimes called, so that it doesn't grab when fed into bronze, and you're there. So there you go, something a bit different, but just showing how every now and again sometimes you have to make a tool to actually do the job. And then this is why I wanted that modified drill, as you saw earlier. So there we have one remetalled big end, which has had the pad hole knocked out. Our proto pad, a special guest appearance by the one and only Mr. Chris Kelly of the Boiler Shop. Thank you very much, Sheffykins. And then the idea is that said pad should insinuate into the orifice, like so. Oil will be fed into the top of this from a reservoir in the rod, and then on the inside you'll see on the pad sits flush with the bearing surface and will supply oil to the crank pin. So there you go, oil pads and how they work and how they're fitted. Right, so here we are with one of the new rod brasses for 825. This is the right-hand intermediate brass. Now, it's been turned to size on the outside diameter here. We've tidied up the flange here, so that's the correct distance. We've got the end-to-end right, and we've also put a radius into the end. The next job it needs these two features adding. The first is the semicircular groove here. The second is a drilling here for an oil pad. Now, the oil pad we're altering. Originally, it was a strip pad like these. I don't like these. They're awkward to fit. I don't think they lubricate very well. So instead of the strip pad, that's being replaced with a round pad. You saw me making these earlier. And so we'll put it's 1.25 inches, I believe, round pad in there to lubricate the bush. And then we've got this groove here. Now this serves as an alignment. There's a taper pin in the rod that goes into this groove here, and that then aligns the bush in the rod so that you're sure that that oil pad is in turn aligned with where the oil's fed into the rod, okay? So next thing, we'll be milling the groove. Right, just a quick in-action video here. Here we've putting the semicircular groove into the periphery of the intermediate bushes for 825. This acts as a locator that a taper pin locates into to align the bush within the rod. So I'm doing this with a Bullnose slot drill cutter. We're running it quite fast on quite a slow speed because, to be honest, that's what a slot drill like this likes in brass, and it's working quite nicely. What we're going to end up with is something that looks roughly like that. You can see the groove in the old bush here. We're going to finally fit and finish it after it's been pressed into the rod. This is just removing the bulk of the material for the for the job to be done, okay? So in a minute we should be able to see it with the finished groove, and we'll be drilling it to the oil pad. And there you go, folks, one oil pad hole drilled. Knocked out for the larger oil pads, which were made earlier in the week and have been quietly pickling ever since. You can also see the shortened blacksmith's drill I pointed to camera earlier. This is why I wanted that special drill, because as you can see, I'm doing this on the radial drill, and the drill arm is all the way up to the top of the column. So that's the maximum amount what I call daylight I have under the spindle. And because the process of drilling these holes out involves a series of repeated drill changes, it's easier and quicker to use a chuck than it is to have to knock them in and out the tape all the time. And so there you go, that's why we modified it, and that's the job it did. So those just now need a little bit of deburring, tidying up, and they're ready to be pressed into the rods and done. So anyway folks, I hope you found it interesting, educational and informative as always. Take care, and I'll see you around.